Good day everyone. Today we will talk about chapter 6 on two-port network. This is part 1 lecture. The content of this chapter will be the introduction of two-port network. We will compare the two-port network to one-port network. And we will look into the impedance matrices of two ports and also the admittance or Y matrix of two port. And we will look also into the terminated nonlinear two-port network. Okay, let's look into the first parameter, which is called as impedance parameters. That is your Z parameter. Okay, so this is the long name impedance, but the symbol is Z. So you can call it as impedance or simply said as a Z parameter. What is it actually? So if you look into this is actually a linear network, or you maybe have many circuits inside this. This is your terminal input and the output terminal, or you have input port and the output port. So remember that for a two-port network, you must relate the voltage and the current based on the terminal equation. So if you have this equation, your V1 equals to Z11 I1, that is your current entering from input port, and you have Z12, that is your impedance from from the input port to the output port times your I2, and for the V2 is the voltage at the output port. So you can always relate this to the current from the input port and also current from the output port itself. So this is actually Z11, Z12, Z21 and Z22. That is your Z parameter, which can relate your voltage terminal with the current terminal. Terminal current, sorry. V1 is the terminal voltage, which can be related to the terminal currents from I1 and terminal current from terminal 2. So please remember this one, because this the important equation. V1 equals to Z11 I1 plus Z12 times I2. And the second equation at the output port can be taken as V2 equals to Z12 I1 plus Z22 I2. Or you can represent this into matrix. V1 and V2 equals to this matrix. Or this also can be related by setting up your I2 equals to 0. So by setting your I2 equals to 0, this is your I2 equals to 0, you actually try to find Z11 and Z21. By setting your I1 equals to 0, setting this into 0, by setting this into 0, you actually want to find Z12 and Z22. So in one time, you can only define I2 or I1 equals to 0. Okay, in order to make sure that you can find the Z parameter at particular terminal. Okay, this is the equation just now where you set your I2 or I1 equals to 0. So setting I2 equals to 0, you actually find the Z11 and Z21. By setting your I1 equals to 0, I1 equals to 0 here, you are finding the Z12 and Z22. Please do not remember this one, because this is actually from the terminal equation. V1 equals to Z11 I1 plus Z12 I2, and V2 equals to Z21 I1 plus Z22 I2. So this is your terminal equation just now. So arranging this one by setting either I1 or I2 equals to 0, you get this equation. Okay, so Z11 is actually open circuit input impedance. Z12 is the open circuit transfer impedance from port 1 to port 2. So the notation you can see here, 1, 2 means it's from port 1 to port 2. Z21 is the open circuit transfer impedance, because Z is impedance. And the open circuit is how you want to do the analysis later. By open circuit, the terminal input or terminal output. So Z21 Z21 is the notation from port 2 to port 1, while your Z22 definitely at your output port. So this becomes your open circuit output impedance. Okay, you have one input impedance at the input port. You have Z22 as your open circuit output impedance at the output port. And you have two transfer impedance from port 1 to port 2, or you have open circuit transfer impedance from port 2 to port 1. Okay, so this is the equivalent circuit based on the terminal equation. Okay, so this circuit can only be drawn if you have the information of Z11, Z12, Z21, and Z22. Okay, so this is the equivalent circuit. Okay, this is the step how you can find the Z11 and Z21. Remember, by setting the I2 equals to 0, you can get your, by setting your I2 equals to 0, you can get your Z11 and Z21. So this one you start into 0. How you can get I2 equals to 0? I2 equals to 0 can be obtained by setting your output port as open circuit. So this is open circuit. Okay, this is open circuit. Okay, by setting open circuit, definitely you have no current flowing into the terminal. But remember that open circuit gain a voltage. Sorry, it gains a voltage at the output circuit. Output circuit has a voltage, but it has no current. So this is what you do. You have V2, but you don't have I2. So this is how you set your I2 equals to 0 by using or by applying open circuit at the output port. Okay, then only you do the analysis over here. Your V1, this one equals to what? This can be solved using, this can always be solved using terminal device or KVL. Okay, so the output port is open, is setting by I2 equals to 0, and the input port, we apply a voltage source over here. Okay, remember, these two important parts. One, you need to make sure it's open at the output port, and second one, you replace the or put a voltage source at the input port. Then only you can solve this equation, V1 and V2 equals to 1. So now you have V1 equals to Z11 I1. Then simply by rearrange this equation, you should get your Z11. Okay, V2 is Z21 I1. So by having I1, you already have I1. Okay, you have I1 in terms of V2. So we can solve for Z21. Okay, this is the step. Step 1, change the apply the open circuit at the output port. Second, you replace or apply a voltage source at the input port, and then we solve for Z11 and Z21. Okay, so this is the step to solve Z11 and Z21. So we still have another parameter, or the matrices have not been completed. So we need to find Z22 and Z12. Okay, Z12 and Z22 can be obtained by setting the input port open. So input port, we replace this with open connection. So this one we change into open circuit. Okay, by setting open circuit, you actually replace the current with 0. Okay, it must be 0 by putting open circuit. If you put a short circuit over here, means you got current here. So that is wrong. By setting the output port to open circuit, you actually set the I1 equals to 0. Then only you can solve this equation. So this one is 0, this one is 0. Then only you can obtain this equation and also this equation. Okay, so the output port, we apply a V2. Okay, so similar to what have you done in step 1. We also can rearrange this equation. Z12 equals to V1 divided by I2, and your Z22 will be V2 divided by I2. Now, in the Z parameter, there will be a reciprocal network. So what is actually a reciprocal network? If the voltage source and ideal emitter connected to the ports are interchangeable. If the voltage source and ideal emitter connected to the ports are interchangeable, so you can say that your network or Z parameter is a reciprocal network. So you have the current and the voltage source. Either you put at the output port or you put it at the input port. There should be no difference for the emitter reading and for the voltage reading. Okay, so the current at the output port should be similar to the current at the input port. So linear network with no dependent sources will be called as reciprocal. This is only applicable for the circuit with no dependent sources. If you have dependent sources in your circuit, then you can't find the reciprocal network. Okay, so what happened is, during the reciprocal network, your Z12 should be equals to Z21. And it can be replaced with T equivalent circuit. Remember that your circuit before this called Z parameter. The equivalent Z parameter circuit is, you have this part is different. You have something that this is your input, and this one is your at the input part, and this one at your output part. Okay, so by doing this, by finding the reciprocal network, you are actually eliminating this part to be a T equivalent circuit. So your Z12 is now same with Z21. That's why you can replace it with only Z1. Okay, but in order to get this, the input Z parameter should be Z11 minus Z12, and your Z22 minus Z12 will be your new output impedance. Okay, so remember we have Z parameter equivalent circuit, and also we have equivalent T equivalent circuit if you have a reciprocal network for Z parameter. Okay, another one will be called as symmetrical. A network with mirror-like symmetry is called as symmetrical. In the symmetrical part, your Z11 will be equal to Z22. So in the symmetrical part, it will be look like this. Your Z11 equals to Z22, and this one is your ZT. While you can also have like this, ZC, and this is ZT and ZT. In example 6.1, we have given the following circuit. We have this equation. Please determine the Z parameter. So in order to get the Z parameter, you need to analyze the circuit. Analyze the circuit with any theorem that you know or you have already learned. Okay, so we look into this. Definitely this part will be your input port, and the V2 here will be your output port. So the one that you want to solve is actually at this part from 8 ohm to 20 ohm. The first step you need to do is to find or to write the terminal equation. So the terminal equation, we get it from V1 equals to Z11 I1 plus Z12 I2, and V2 equals to Z21 I1 plus Z22 I2. So by doing this, what actually you do is you try to transform or you try to solve the circuit. Okay, by setting the output port as open circuit. So now we apply voltage as the V1. Okay, now you can solve this by, maybe you want to use circuit reduction technique. Okay, by doing circuit reduction technique, you will have 10 and 20 will be series, and then 30 parallel to 20 plus 8. That will be your 20 ohm. So Z11 will be 20 ohm. And Z22 for this part will be okay, so you have Z11 and Z21. Sorry, for Z21. So for Z21 is actually using Z21 is actually solved using V2 divided by I1. Okay, so your I1 just now will be equals to 20 I1. Oh, sorry. Your V1 just now should be equals to 20 I1. Okay, so for Z21, it's actually V2 divided by I1. So your V2 is the voltage drop at this particular voltage resistor. So V2 is taken as to solve this part, you should get V2 divided by okay, you should get 8. So Z21 and Z12, you should get 8 times I1. Okay, 8 times I1 divided by I1, so you get 8. So meaning that your Z21 will be equals to 8. Okay, then only you solve for the second part where you solve for Z12 and also Z22. In Z22, we replace input port with open circuit and the output port as voltage applied to that particular port. Okay, so we solve this one and we should get this equation. Okay, so your Z12 will be equals to 8 and your Z22 should be equals to 12. Okay, now you can solve this. Your Z11 is 20, your Z12 is 8, your Z21 will be 8 and Z22 equals to 12. So remember, by looking at these two, the Z12 is now equals to Z21. So we can conclude that this circuit should have an equivalent circuit, which is T equivalent circuit, or is actually a reciprocal two-port network. Okay, reciprocal because your Z12 is equals to Z21.